This video I am going to explain block diagram reduction technique. Watch the entire video without skipping. This one video is enough and you can solve any big block diagram problems. First of all, what is block diagram? Block diagram is basically a modeling of any simple or complex system. Here let's see the example. This is a simple system. It consists of only one block G of S. Here input R of S, output C of S. This is the simple system block diagram. Then another one is complex system. This complex system consists of number of blocks G1, G2, G3, G4. Then feedback loops H1, H2. These are the gains. Then the summing point. These are summing points. Then takeoff point. This is the takeoff point, or another name of takeoff point is branch point. Then input R of S, output. This complex system consists of number of blocks, number of summing points, and the takeoff point. So the block diagram is basically a modeling of any simple or complex system. Before going to reduce the block diagram, we know some important rules. Let's see the 11 rules. Rules of block diagram algebra. The first rule, combining the blocks in cascade. Cascade means two blocks are series. No other connections between the blocks. Here in between these two blocks, there is no connections. Just one block is followed by another block. Here in this case, just multiply this block. The simplification is just multiply this block. Then check the signal. Here A signal is entering into the block G1. The output of this block is A into this block gain G1. A into G1. Then A into G1 gain is entering into G2. Then the output is A into G1 input into this gain. A into G1 into G2. Now check, these two blocks are just multiplied. The output is A into G1. The simplification of this block is this one. Two blocks are in cascade. Just multiply these two blocks. Then second rule, combining blocks in parallel. The starting point is branch point. The two blocks, two arrows are enter into a summing point. That is a parallel block. The blocks is look like means just add these two blocks. That is the simplification. G1 plus G2. Then third rule, moving the branch point ahead of the block. That means the moving the branch point after the block. After the block, here add 1 by G. Then only it satisfies the output values. Then rule number 4, moving the branch point before the block. Here this is the branch point. Move the branch point before the block. This rule is reverse of rule 3. The previous rule, inverse of G is added in this branch, feedback branch. Here just multiply the value. The feedback loop, just add this value. Then rule number 5, moving the summing point ahead the block. That is moving the summing point after the block. In this case, this gain value is multiplied in this feedback path. This gain value is come into this feedback path. Then only it satisfies the input and the output values. Then moving the summing point before the block is just a reverse of the previous rule. The moving the summing point before the block means moving the summing point and multiply 1 by G. That is the gain value. This gain value is the inverse of the gain value is multiplied in this feedback path. Then interchanging of the summing point. It's directly interchanging the summing point. Here we can draw this first summing point in the second, then second summing point here in first, then here A, C, then B, C. The output is same. Then splitting of summing point. More than two connections are there in the summing point means we can split the summing point for our simplifications. Here this is first of all split A and B plus plus, then the output is splitted, C is splitted separately, A plus B, here C is minus, the output is A plus B minus C. The ninth rule, combining the summing point. This is just a reverse of the previous rule. We can combine these two blocks. This minus only added in anywhere. That minus sign is, the minus side input is C. Here this is minus. This one is minus. Then eliminating of negative feedback loop. This is important. First of all, identify the feedback loop consists of one forward path, another one is reverse path. Here the forward path is start from the summing point and the feedback loop is enter into the summing point. This is on loop. Here this is input, this one is output. In this case, the elimination is G divided by 1 plus G into H. Forward path gain divided by 1 plus G H. Here the feedback is negative feedback. Here put positive. Suppose the feedback is positive, this sign becomes negative. That is the 11th rule. Elimination of positive feedback. The formula becomes G divided by, that is forward path gain divided by 1 minus GH. The minus, the reason for here minus is, here this is positive feedback. The positive feedback means here put negative sign in the formula. These are the important rules. These rules are well known means easily reduce any complex block diagram. Now let's see one simple example problem. Reduce the block diagram shown in figure. Find C divided by R. That is the Laplace transform of output divided by Laplace transform of input. Find the transfer function of the block. Before going to solve this problem, you remember all these rules. Then first rule is a cascading block. Then second rule, the parallel path. This problem consists of two takeoff points, two summing points, and four blocks. First of all, we need to see if there is any direct cascade blocks or parallel blocks. Just to look the blocks. Here there is no direct cascade blocks and no direct parallel paths. So second step, try to move the takeoff point any side, that is for after the block or before the block. See if you can reduce the block. I am going to move this takeoff point after the block G1. After the block G1 and connect between this line anywhere, here or here, here, here. Suppose move this takeoff point here means these two blocks, these two are parallel. This is forward path, this is also forward path. This is a parallel block. Then this side, this is forward path, this one is feedback loop. So this is the feedback loop. So this is the feedback loop. So here the step number 1 is move the branch point after the block. The rule is the multiply the inverse of this gain value in this feedback loop. The inverse of gain value is 1 by G1. Here the 1 by G1 black is added in this feedback loop. Here this branch point is moved here, then the feedback path Here added 1 by G1. Now combining these two blocks in parallel. This is forward path, this is also forward path, combining the blocks in parallel. And also eliminating this feedback loop. The parallel, these two are in cascade. Just multiply G3 divided by G1 plus G2. This one is G3 divided by G1 plus G2. This is negative feedback G1 divided by 1 plus G1 H1. Negative means here put positive. G1 divided by 1 plus G1 into H1. Now these two blocks are in cascade. Cascade, in between these two blocks there is no connections. Both are connected series. So cascade. Just multiply these two blocks. Multiplying. Here in the second term take LCM. G1 is the LCM. So the G1 term is multiplied here. Now the G1 and G1 are cancelled. Therefore, the transfer function C divided by R is equal to, that is C of S divided by R of S is equal to G1 G2 plus G3 divided by 1 plus G1H. Now let's see the second problem. Here in this problem, there is no direct cascade block and there is no direct parallel block. So I am going to move this takeoff point or move this takeoff point after the block or move this takeoff point before the block. Moving this takeoff points, you get any simplification means move that takeoff point, or otherwise there is no simplifications or reduction is possible. No reduction is possible means then goes to move the summing points. Summing points after the block or before the block. Then only you can reduce the block easily. Now I am going to move the second takeoff point before the block G2. Before the block G2, that is step number 1. Step number 1, moving the branch point or takeoff point. Branch point before the block G2. Before the block G2. The rule is this branch is move here. This branch is move here. So in this branch, here in this branch, add this block or multiply this block. This block is added in this branch. Here G2 is come in this feedback loop. Therefore, this block diagram becomes, I am going to redraw this block diagram. Here this branch is move before the block G2, this branch point. So this branch, the feedback branch becomes, already here on H1 gain is there. This gain is added in this block G2. This point is move here. Now, these two blocks are in cascade. Then these two blocks are so in cascade. And this is the parallel path because these two are forward path. So this is the parallel path. Then step number 2, combining the blocks in cascade and eliminating the parallel blocks. Combining the blocks in cascade and eliminating the parallel blocks. Therefore, the block diagram becomes first of all, I combine, just multiply G1 into G3 plus G4, parallel block. So combining this block, G2 into G3 plus G4. G2 into G3 plus G4. G2 and G3s are cascade. Then G4 and G2, G3 is a parallel block. So add. These two are cascade, just multiply Kaichon G2. Then third step. Also I am trying to move this takeoff point after the block. Here move this takeoff point after the block means this block, the inverse of this block is added in this feedback path. That is 1 divided by G2, G3 plus G4. Then this is also takeoff point. We can draw this takeoff point here or here, or this point is draw anywhere in this place. Step number 3, moving the branch point. Moving the branch point. After the block G2, G3 plus G4. Also split these branch points. Split these branch points, draw separately. Therefore, this block diagram becomes H2. I draw the takeoff point separately here. Then move this takeoff point after this block. Here already H1 G2 is there in this feedback path. Just copy this one. Then this after the block, this takeoff point is moved after the block so that the inverse of this block is added in this feedback path. That is equal to 1 divided by G2 G3 plus G4. Draw here. Now look at these blocks. Here these blocks are in cascade. This is forward path. This one is reverse path. Eliminating the negative feedback loop first. Then step number 4. Eliminating the negative feedback. This is the negative feedback. There is no change in the remaining blocks. I just copy the remaining blocks. This block becomes G2 G3 plus G4 whole divided by 1 plus, because this is negative feedback, so here put 1 plus G2 G3 plus G4 into the reverse path gain H2. Because the formula is G of S divided by 1 plus G of S into H of S. G of S is the forward path gain. H of S is the reverse path gain, feedback loop gain. This block is eliminated. Now these two blocks are in cascade. Just to multiply these blocks. H1 G2 divided by G2 G3 plus G4. This is C output. Now look at the blocks. Here, these two blocks are in cascade. Just to multiply these two blocks. After that, this is forward path, this one is reverse path. So this is the negative feedback. Again, negative feedback. I'm going to do the step number 5. Combining the cascade block and eliminating the negative feedback loop. Therefore, this block diagram becomes, just to multiply, the remaining blocks are same. Here plus minus. We are multiplied this one, G1 into G2, G3 plus G4. Then eliminating this cascade. Now the forward path gain is G1 into G2, G3 plus G4 whole divided by 1 plus G2, G3 plus G4 into H2 whole divided by, this is a forward path. Then 1 minus, here minus feedback, so here put 1 plus, this is forward path, G1 into G2 G3 plus G4 whole divided by 1 plus G2 G3 plus G4 into H2 into the negative feedback, the feedback path gain H1 G2 divided by G2 G3 plus G4. Here C. These blocks are eliminated. Here R. The last step again, this is forward path, this one is negative feedback loop, unit feedback, eliminating this feedback loop, eliminating the negative feedback loop. Before going to eliminating this negative feedback, simplify this block. Now I am going to simplify this block. Here in the denominator G2 G3 plus G4, here also G2 G3 G4, these two are cancelled. Then after that take LCM, the denominator term LCM is 1 plus G2 G3 plus G4 into H2. Writing the numerator term G2 G3 plus G4 divided by 1 plus G2 G3 plus G4 into H2 whole divided by the denominator term. Take LCM. Here the LCM is 1 plus G2 G3 G3 plus G4 into H2 here 1 into this term, so 1 plus same on G2 G3 plus G4 into H2 plus the second term. The second term is G1 into H1 G2, that is G1 G2 H1. Now these two denominator terms are cancelled. These two denominator terms are cancelled. Therefore, this equation becomes, that is equal to G1 multiply inside G1 G2 G3 plus G1 G4 whole divided by 1 plus H2 is multiplied inside G2 G3 H2 plus G4 H2 plus G1 G2 H1. Now simplify the final block. This one is the simplification of this block. Now finally one feedback loop is there, eliminating the feedback loop. Step number 6, eliminating the negative feedback. Again, negative feedback path, this is unity feedback path, unity, so H value is 1. Therefore, this is the forward path gain. Therefore, the C divided by R, C divided by R, the transfer function C divided by R is equal to the forward path gain G1, G2, G3 plus G1, G4 divided by 1 plus G2, G3, H2 plus G4, H2 plus G1, G2, H1 whole divided by 1 plus, because it's also a negative feedback. Negative feedback, the formula is G of S divided by 1 plus G of S into H of S. This is G of S, G1, G2, G3 plus G1, G4 whole divided by 1 plus G2, G3, H2 plus G4, H2 plus G1, G2, H1 into 1, the unity feedback. So into 1. Then take LCM. Both the denominators are same. Therefore, the C divided by R is equal to, the LCM is this one. Then the denominator and denominators are cancelled. Therefore, the transfer function G1, G2, G3 plus G1, G4 whole divided by the LCM of this one is the denominator term. Write the denominator term, multiplied this 1. So the same value becomes 1 plus G2, G3, H2 plus G4, H2 plus G1, G2, H1 plus this term plus G1, G2, G3 plus G1, G4. The numerator this term and the denominator this term both are cancelled after taking this LCM. This is the final transfer function of the given block diagram. This is the reduced formula. This is a simple reduction technique. First, remember all the reduction formulas in the mind. Then after that, move the takeoff point after or before the block. Then only you can reduce the block. Or it is not possible means second step, move the summing point after or before the block. The blocks come under the rules. Then you can start the reduction. Then step by step reduce the blocks. Then finally get the formula. That is called the transfer function of the system. That's all. Thank you.